Hi, everybody, and welcome. My name is Ubaida Abdulai, and I'm excited to moderate today's session, Practical Gen AI with Python, Beyond the Hype. So we are talking about generative AI with Python, but not the hype version, the real version, the messy, practical engineering version. Python is still the language people use to experiment and build, and the field is shifting from demos that look cool to systems that are reliable, that are safe, and that are valuable. So today we are looking at what works, what doesn't, what skills matter, what ethical considerations should we focus on, and where this is going in the next few years. So basically, how to ship things that matter and not just talk about them. Please join me in welcoming our panelists. We have Jodie.
Hi,
We have
really nice to be here.
Hi Jodie,
Hi.
Jessica. We have Una. Hello,
Hi.
and we have Iulia.
Hi.
Hello. So I'll have them introduce themselves now, and then we'll get started. Jodie, you can go first.
So, hi, I'm Jodie. I'm a data scientist and developer advocate working at JetBrains, and I have a background in natural language processing.
Thank you, Jessica.
Hey everyone, I'm Jessica, use she, her pronouns. I'm a machine learning engineer at Ecosia, which is the search engine and now AI company for a better planet. And I'll pass over to Una.
Hi, I'm Una. I'm head of artificial intelligence at International Ground Engineering Company. I also run PyLadies Amsterdam for a bunch of years now. Yeah, and do other cool stuff. Next to the next one.
Hi, everyone. I'm Iulia. I also have a background in data science and NLP, and these days I focus more on making engineering content and talking about robotics and physical AI and cool stuff on the internet.
Thank you all, and we are honored to have you here. Now let's cut through the noise and talk about how to build GenAI that lasts and not just impress people. So I'm going to start with Jodie. GenAI has grown incredibly fast. From your perspective, especially coming from academia and your early industry roles, where did the field start and what early Python tools or experiments laid the groundwork for today's ecosystem?
So, I was saying to the panelists before we joined that I actually wrote half a page for this. So, I'm going to try and just pick out the relevant bits. So, this is a long story, but kind of the shortcut of it is current Gen AI belongs to two fields, natural language processing and computer vision. And our current iteration of those, or the kind of generative AI models that we're seeing, are based on neural networks. So neural networks really took off in around 2012 with the development of an image model called AlexNet. But things really took off with the current boom with the development of the transformer models. But there are a lot of steps along the way. So after AlexNet, one of the biggest sort of innovations on the Python side was the development of TensorFlow in 2015 and then PyTorch in 2017. And Google is actually doing a lot of work in this area. They're the ones that developed and released TensorFlow. Then they actually developed this extremely cool model called Word2Vec, which is, created the idea of word embeddings, which is a foundational part of LLMs. And you can still actually play around with word embeddings, just creating them yourself from scratch on data sets with a really nice package called GenZim. I used to use this a lot in my early NLP days. And then the sort of early tools we had for LLMs were like ones that made the really early open source models like BERT available. So I remember paying this package called Flare from Zalando, like all the way back in 2018, 19. But we have much better tools now. So we have the Transformers package from Hugging Face. We have things like LangChain, LangGraph. We have frameworks like LLM Lite, Olama. So the ecosystem is much more sophisticated, but those sort of earlier building blocks are still there for training your own neural networks and also like working with earlier components like word embeddings.
I love the context, especially the early tooling. But let's talk about what's happening now and what's actually working. So, Iulia, I want to ask, where is Gen AI now in terms of tools, capabilities, the real world adaptation, and the practical Python applications that you are excited about right now?
Yes, thank you, Jodie, for the awesome intro. I remember when I first was doing my data science bachelor working with Tuvek and the whole like king minus man plus woman equals queen. And that was like the coolest thing ever.
It was amazing.
We've gone a really long way since then. I think people kind of take it for granted now that you have these amazing models like at your fingertips that just work for things that we used to have to like train overnight to get any meaningful results. And now it feels like you have this rocket ship that you can kind of use for anything and everything. Maybe overuse it a little bit, I would say as well. I think the field is changing super, super fast these days. And it's very difficult to like pin it down or figure out what technology to use, especially like with all the new model versions, all the new API specifications and the way that they shift a lot so much. It's quite difficult to like implement it without it shifting underneath you like sand. But that being said, one part that I am particularly excited about is using the GenAI models and transforming, like we're going from LLMs that Jodie described so well to like vision language action models. So using the multi-model approach where you can also add image and video to it, you can start to generate a lot of super meaningful insights beyond just text. So for example, applications in robotics and physical AI, that you can use it for robots to kind of get a feedback of their environment and determine what actions should they take next. So you no longer have to like program every single movement or every single like physical representation of the world. And instead you use kind of the same way that ChatGPT could give you an answer, it can also tell a robot like how to move. And to me, that's like the most cool part that I've seen, because I would rather have like a robot that learns to do my laundry than like a ChatGPT app on my phone. So that's where I'm super excited to see stuff happening.
There's this misconception that AI is coming to take our jobs. So before we quit our jobs because of all the amazing things you said you can do, let me ask Jessica, there's so much buzz, but when you're building Gen AI systems in the real world, like at Ecosia, what should teams actually focus on to create lasting value?
So I think what's really important is, first of all, think about what is the user problem that you're actually solving, and is Gen AI as a technology the right solution? Like, what is it actually adding? What is it bringing? I mean, like, of course, there's not only generative AI, there's all the like different, it's like an umbrella term essentially for different types of machine learning. But especially with generative AI, because it's also large language models that need to be used, really thinking about what is the worth of adding that to your solution. And then I think from more of a technical standpoint, it's really thinking about how can you make it scalable? And it's still really a lot of foundational engineering things that we think about, of like, how can we make a resilient and robust system that matches our user needs and kind of continues to work at scale. And a lot of those things are just good engineering practices at the end of the day. They're not actually that new, even if the technology of connecting to a large language model is. The last thing I would say is also just thinking about where it's running and who you're partnering with. So I think this is something that's very important. A lot of the hype and the buzz can kind of mask, but we need to not forget these things.
Okay, thank you, Jessica. That perspective is quite grounding. Now to Una, I'd like to know, for developers and teams working with Python, what skills, practices, or even mindsets are important to not just keep up, but to build responsibly and sustainably in this Gen AI era?
Oh, that's $1 million question, I would say. Really nice one. I just want to bounce back for a second to what Jessica mentioned. I really like that you said, like, there are a lot of things that technology is changing, but there are some ground practices that are still here, like the good engineering practices. So if we split it into the, let's say, technical component and more or less soft skills component, technical component would be, again, don't build everything from scratch, reuse what's already there, see how this could be adapted to your specific use case. Whether we're talking about should I develop specific library from scratch because I'm not satisfied with the current offer? I would say maybe not from the very beginning. You can see what's already around. There are millions of fantastic open source libraries here. Just go and grab. And if you feel uncomfortable, just open a PR. Maybe someone else feel the same, and you will, in this way, you will just contribute to the society in a better way. And from, let's say, less technical perspective, especially with GenAI part, when you process a lot of unstructured data, such as or text, or is it, let's say, audio or video, what is very, very important is collaboration skills and understanding the cost of subject matter expertise. Because I see usually proof of concepts, now you can build in a couple of hours. Here we go, it's easy, like we are ready to ship. And let's say the stakeholders are psyched over that. Yes, let's just ship it right now. But they completely forget about this evaluation part. And I would say that the whole GenAI idea is now switch the way how we develop GenAI applications to evaluation-based driven development. So instead of doing just building and keeping evaluation as the latest item in a backlog, which would be probably never picked up, I would say refocus on introducing it, let's say from the week 2. Let's give 2 weeks just to play and fool around, but from the week 2, you need to basically invest in that. That what for me would be the most important ones.
Okay, I think those are really practical. And of course, once team starts building, things will get messy quickly. So for anyone here thinking about how it plays out in practice with all that Una has said, I'm going to ask Iulia, what are the unexpected challenges, technical, operational, or even cultural, that you have faced when moving a Gen AI prototype into a real maintainable application?
Yeah. So I'll share some insights that I've seen at various customers who have tried to do it that we've talked with. Part of it is what I was mentioning earlier as well, the fact that it shifts so much, and every time a new model comes out, they might change the way that the code around it works. So if you've put something in production and you just want to upgrade the model, you might need to actually go in and make quite a lot of changes, and things break, and a lot of people and a lot of teams have to be called to get into it and fix it. And because it moves so fast, it's also very difficult for large organizations to implement, where they have these standing processes that take a lot of approval and a lot of evaluation before they can implement something. So by the time it goes through all the departments that it needs to go to, you no longer want to use that model, or you want to start over with a new approach. So it's a bit difficult to implement in larger scale places where things don't move so fast. I think it's really cool for trying out and experimenting, but we're really missing that robustness and the big engineering practices that Una mentioned as well. And I think a very unexpected pitfall that I did not know about and was quite surprised to hear is that even if you have a model in production, it worked well, you even did the evaluation and everything was fine, but you get to a point where it's live and you reach a quota of tokens. And some applications have this, that if the tokens just get super, super busy, they'll just stop working. So even if you've paid for your subscription and everything is supposedly running smoothly, you run out of tokens and no one can make calls to it. And there's not much you can do other than pre-order tokens for a particular time. So you have to pay in advance, even if those tokens will be used or not. So that kind of goes against the cloud principles of scaling and pay as you go. So I'm seeing a lot of issues and pitfalls with the way that it's going in production. And I'm not sure it's completely ready. So I would be really aware of that when you try to implement something and scale it.
That's so relatable. I know a couple of engineers, myself included, that fall into that trap. But let's zoom out and let's consider the ethics of what we are building. Jessica, as GenAI becomes mainstream, how should we approach bias, transparency, and the ethical guardrails especially in Python, where projects can scale up rapidly? What should we consider and how should we approach it?
Yeah, great question. And I think just to mention on the point that was just made by Iulia is that a lot of the challenges that I see right now are actually like with Gen AI products is actually way more to do with UX, like user experience, than it is to do with the technical solutions. So like in the end, a lot of companies are calling APIs and they're relying on like these token quotas, like you just mentioned. But I think the big challenge is like how you communicate that to users, because this like natural language interface of like a chat, it's not new. We all remember the chatbots before LLMs and how fun they were. But there is a lot of nuance in there now about how we navigate them. And I think this is very also relevant when we think about data privacy, ethical considerations, bias, and responsibility in AI. So I think most people at this point understand that large language models can produce content that seems very convincing, but may not be factually accurate. And I think it's very important as technologists, we understand actually the challenge of being able to communicate this well to the users. So I think there's like the UX side, but then there's also the technical backside of that when we think about like data collection. So people I have observed are a lot more open to putting a lot more personal data into these kind of interfaces. And therefore, we kind of need things to remove personal identifiable information, PII. We need things to think about when it's appropriate to interact and when it's not. We've seen multiple cases around people being encouraged to commit acts of violence, or for children to have inappropriate conversation or age inappropriate conversations. So I think we really have to think about what we're releasing, first of all, into the world. And unfortunately, I will say a lot of the generative AI projects I see become a bit of an everything machine. And when it's a bit of an everything machine, it's very, very hard to scope down to what we actually want to monitor. So I think one thing I would think about is just really, first of all, educating yourself on what responsible AI looks like. And I can maybe share some books later in the channel that I've been reading, but also think about specific scopes where you can start to make meaningful, measurable impact. Probably you can't just make the whole project unbiased. We've seen how that goes, because then you end up with like kind of like the antithesis of this, where it's like trying to diversify everything in a way that also probably is not appropriate.
Okay, thank you for that perspective. There are always trade-offs when you're trying to build unbiased systems. So I appreciate that. But with that in mind, where is all of this actually going? Una, where do you see Gen AI in the next few years? What emerging applications or risks? We're actually seeing some of the risks already, but what do you think Python developers should prepare for?
I see it as a kind of a scale. So on the one side, that would be this ultra, let's say, ultra multi-modality of, it's like one thing that rules them all, that you can do everything with that, and process video and, and parse text and whatever comes to your mind. On another side of the spectrum, I see this more deep specialized domain models. For example, if we're talking about text, then probably we're gonna talk about more sophisticated, energy efficient, let's say lightweight, small language models. If we talk about agentic systems, maybe it would be some kind of swarm of multi-agents where each particular node in the swarm is, let's say, focuses on a specific task. Again, very domain related, very having like predefined, let's say, physical boundaries. So it makes it much more easy again to control or monitor. So for me, this would be which road we're going to take. Are we going to take this broad, bright, shiny road to this, let's say, biggest, very big scope applications, or whether we go into this tiny, small thingy. I don't have answer to that yet. Let's say we'll figure out. But that, I think, where we are going in the next couple of years, at least.
Thank you. That's awesome. But let's bring it back to the individual developer or teams that are trying to make impact now. Jodie, for someone who wants to move beyond tutorials and hackathons, what should they focus on first? Technically, strategically, or even creatively to build impactful projects?
So the other three panelists have already made a number of like amazing points that I jotted down for this question. Things like choosing the right model, things like evaluation. One point I do want to say about evaluation is evaluating NLP systems, particularly NLP systems that generate text, is really difficult to do, particularly difficult to do in an automated way. And you should be prepared for the fact that your evaluation data is going to be a significant time investment for you to create. But kind of just like the main point I would say, and I think maybe Jessica or Iulia already touched on this, is the idea of picking the right problem. And I'm not just talking about the right problem in terms of the domain. Obviously, it's super important because you need to understand the domain to be able to build an effective system. But picking a domain that's suitable for an LLM, I'm not going to talk about vision models because I'm not a super huge expert on those, but I think LLMs seem a bit magical, right? Like they seem like they can do all these things that we can do. But when you actually look at the papers, like Apple has had a number of really nice papers coming out about the reasoning abilities of LLMs. Even these so-called reasoning models tend to fall apart beyond a certain level of complexity. So even if you're looking at building an agent or applying an LLM to more complex problem decomposition, it's better to have a narrow domain, pick an appropriate model for that problem domain, and try to limit the scope of what you're asking your application to do, because they're just machine learning models. They're trained to do a specific thing. And if you try to overextend them, the performance is going to start to get very shaky. So don't try and do everything. Just think about problems like we always have. Just try and solve a problem and do it well.
That's perfect. So the tip is to try and solve a problem. I'm going to stay on you, Jodie. As a developer advocate, what open source Python tools do you think are underrated for GenAI?
Yeah, so I've already talked about a couple of the big ones. So I've talked about things like Ollama, LangGraph, LangChain. Everyone knows about them. I mentioned Light LLM, which I'm a big fan of because it's this really nice sort of unified, lightweight API layer that allows you to connect with all sorts of model providers. So I'm a big fan of trying to use open source models when you can, because a lot of these privacy concerns, a lot of these environmental concerns are addressed, and you can pick smaller models that focus on specific domains. They have their own problems with production. Deploying any huge neural network is hard, right? But anyway, I'll get back to the tool. But Light LLM is a nice way of giving you this multi kind of access point for playing with OpenAI models, Anthropic models, Google models, but also all the models on Hugging Face. Spacey LLM. So I'm a big fan of Spacey. I think a lot of us know the creators of Spacey. They're amazing. But Spacey has been this sort of juggernaut of natural language processing for a really long time. And I'm talking about classical NLP techniques like pre-LLMs. And they released Spacey LLM, I think, 2 years ago. And it basically gives you these pipelines that allow you to sort of couple classic NLP techniques with LLMs, including using LLMs to do classic NLP techniques like named entity recognition. And then a new one that's out, I'm not actually sure if it's open source, is Pydantic AI. So Pydantic has been doing a lot in the sort of agent space. So they've actually come out with their own agent framework. And I haven't really played with it yet, but their claim is that it's a bit more focused on structured inputs and outputs for the tools. So it's a bit more predictable, a bit less magic than LangChain. So, LangGraph. So yeah, they're the sort of the ones that I would recommend digging into if you haven't kind of gone beyond the big ones.
Okay, I love that. Now, you mentioned environmental considerations. So I'm moving to Jessica.
Yeah, good idea. Don't ask me.
You are building AI that actively helps reduce environmental impact. How can developers evaluate or even measure the ecological footprint of their GenAI projects, and what practical steps can they take to build more sustainably?
Yeah, thank you so much for asking this question. So yeah, we have just released an AI search. And one of the things that I love about Acosure is our business model, which essentially is like 100% of our profits go to climate action. And we put renewable energy into the grid that doesn't just match what our services require to run, but puts more. So it's like not just carbon neutral, it's carbon negative. And of course, first and foremost, you need to be able to understand how you can measure this. So we're using tools like Ecologits for models where we don't have a lot of transparency. These are estimates, just to be very clear. And when they're models that we're running, we use things like Code Carbon, and we've been looking at the energy score, which is a Hugging Face project. So there's tools out there now that will help you get an idea of like how to measure the energy that's being used. They're pretty easy to instrument. I've done workshops on these as well, which I'm also happy to share. People can get started super, super quick, which is really nice. There is still a lot of problems here, though, mostly because there's an absolute lack of transparency from the larger companies. And especially when it's distributed systems, it can be quite difficult to actually say what the energy usage is. And we also have very little numbers around water usage and things like this. We essentially kind of, I think, all have the same picture that data centers are incredibly resources intensive and incredibly harmful also to populations that live around them. But getting exact numbers can be difficult. I think rather than shooting, I think someone said this as well, rather than shooting maybe for perfect in these things, we need to shoot towards moving to better systems and pushing for more transparency.
Okay, thank you, Jessica. Now, to clear the air on the misconceptions, Iulia, engineering content on YouTube. I've watched a couple. What misconceptions about Gen AI do you want to correct the most?
I think a lot of people see it as, like Jodie said, this magical tool that can do all these things. And I keep seeing so many comments of people being like, is programming dead? Is software engineering dead? Is data science dead? Like all of a sudden we're going to use AI to do everything. And I would say it's like almost the opposite, where we need to get back to engineering. That's why I picked the name, to be like, we have to focus on the approach to these problems the same way that we've used for other technologies, like good engineering practices, thinking about why are we building things, how are we going to do it optimally, how are we going to do it in a good way, and not letting AI just magic everything away. We need more people who understand how it works and how it thinks, and especially what its limitations are, like the reasoning issue that Jodie mentioned, like, and the sustainability issues that Jessica mentioned. We need more people to think about it as a tool, and at that, a tool that only works in particular cases and not something that's going to take over and replace the way we do things. So I feel like we're really going in the wrong direction with the image that it has, and hopefully we can correct that with more education.
Okay, that's perfect. Zooming out to the community side, Una, how can PyLadies and similar communities shape the culture of Gen AI development?
Super simple. I have a simple answer for that. So focus, at least of PyLadies Amsterdam, is predominantly on running workshops. And to run workshops, you have to prepare materials. And running workshops means you run them at least 12 per year, which also means that at least 11 from 12 workshops would be given or by female or other underrepresented groups. And I think the more female figures, the more underrepresented groups would be, the voices would be given. and the more knowledge would be shared, it would be very, very, let's say, valuable. And overall, I say, like, as one like takeaway from this conference, or one takeaway from what we discussed so far, for me, it's share knowledge first within, let's say, your company, second within your community, and third, go big and go globally and just share it as we're all doing it right now. So thank you so much.
Thank you all. And this has been a great conversation. So the bad news is Gen AI is harder than TikTok makes it look. And the good news is Python is where we are still figuring it out, and we can do that together. So thank you to our amazing panelists, and thank you all for being here. And go and build something valuable, something ethical, and ideally not just another chatbot. We can do more. Bye.
Thank you, Ubaida.
Thank you. Goodbye.
Thank you. Bye.
Thank you all.